In this video, we're going to look at how to differentiate the following logarithmic functions using the chain rule. To differentiate the logarithmic function using the chain rule, we're going to need to use two facts. The first is that the derivative of the log base e of x function is 1 on x, and that the chain rule states that dy on dx is equal to dy on du times du on dx. So let's begin with our first example. Here we've got the function y is equal to log base e of 2x plus 3. We're going to let u equal to 2x plus 3. This is the argument of the log function. We can now write y in terms of u. So y is simply equal to log base e of u. Then we're going to differentiate each expression. Du on dx is just 2. Dy on du is 1 on u. Then using the chain rule, dy on dx is equal to dy on du times du on dx. That's going to give us 2 on u. Then we need to express u back in terms of x. So we're going to use our original definition. U is equal to 2x plus 3. So therefore, the derivative of this function is equal to 2 on 2x plus 3. Let's look at the next example. Here we've got y is equal to log base e of x on 2. Now this is the same as log base e of a half times x. So we're going to do the same thing. We're going to let u equal to a half times x. So we can now express y in terms of u. Y is also log base e of u. Then differentiating each expression, du on dx is just a half. Dy on du is 1 on u. Then using the chain rule, dy on dx is equal to dy on du times du on dx. And this will give us 1 on 2u. Again, replace the u and express it back in terms of x. So this is going to be 1 over 2 times a half x. And all of this just simplify to give us dy on dx is equal to 1 on x. Our third example, we've got the function y is equal to 3 times log base e of 2x cubed minus 1. Again, we're going to let the argument of the log function be u. So we say let u equal to 2x cubed minus 1. So we can write y in terms of u as y is equal to 3 times log base e of u. Then differentiating each expression, du on dx is 6x squared, whilst dy on du is 3 on u. Then using the chain rule, dy on dx is equal to dy on du, 3 on u, multiplied to du on dx, 6x squared. This will give us 18x squared on u. But then we need to replace the u back and express it in terms of x using u is equal to 2x cubed minus 1. So therefore, dy on dx will be equal to 18x squared on 2x cubed minus 1. Our last example, we've got y is equal to 5 times log base e of the square root of 3 minus x. This time, we're going to let u equal to the square root of 3 minus x. So y is just 5 log base e of u. Now, u is equal to the square root of 3 minus x is the same as 3 minus x to the power of a half. And when we differentiate this, we're going to get a half comes to the front, reduce the power by 1 and multiply by negative 1, the derivative of 3 minus x. And this will give us minus 1 over 2 times the square root of 3 minus x. Whilst dy on du is just 5 on u. And again, using the chain rule, dy on dx is equal to dy on du, 5 on u, times du on dx, this expression, minus 1 over 2 times the square root of 3 minus x. This will simplify to negative 5 2u times square root of 3 minus x. And again, we're going to replace the u with the square root of 3 minus x, and this will just reduce to minus 5 on 2 times 3 minus x. And to tidy this up a little bit, That's 5 on 2 times x minus 3. And that's our expression for dy on dx. Thanks everyone for watching the video. I hope you guys found that useful. For more videos on this topic or other topics, please check out our channel. We do release videos weekly. So if you haven't already, don't forget to subscribe. We hope to see you all in the next one. Bye for now.